I'm Anil Kumar, sharing with you some concepts about relation between velocity, acceleration and displacement in rectilinear motion. The question here is, an object moves in a straight line so that its velocity is proportional to the time elapsed. Prove that the velocity can be represented by the relation v square equals to 2as, where v is the velocity and a is a constant. Now we come across this equation in physics also, and I have provided one simple derivation for this. And now I'm taking this topic under calculus. So we are now working on differential equations. Now, since we are working on differential equations, I will be using some concepts which are very relevant to differential equations, which will help us to derive this formula also, right? So here is, in this video, you could actually connect the two also. Now let's go through the question once again. It says, an object moves in a straight line so that velocity is proportional to time elapsed. We say velocity is proportional to time elapsed. Now what does that mean? So we'll assume this to be directly proportional. So I'm just adding a word to it. When I say directly proportional, that means this is a straight line which goes through the origin, right? So that becomes directly proportional. Well, since that is a result which we are going to derive, so directly proportional, directly word is not being used here, but it is kind of assumed. So what we have here is independent axis represents time, the dependent is velocity, and the straight line represents that velocity is proportional to time. Now whenever you have an equation which says something is proportional, in that case there's always a constant of proportionality, right? So that constant times time will become an equation, and we are given constant as a, right? So we'll use this a as a constant, at. So velocity equals to at. In physics, you have already learned the significance of a. So a, you can see here as basically change in velocity over t, you could say. A is actually change in velocity over change in time, which you can get from here also. And so we treat this as acceleration. So the letter A is actually very, very important letter for us. It really represents acceleration under these circumstances, right? So v equals to at is a standard equation which we normally use in physics to relate velocity with acceleration and time. Okay, so let's move forward from here and see how we derive at this using calculus. So what we have here is v equals to at, right? Now v is actually rate of change of displacement, right? V is equals to rate of change of displacement, where s is displacement for us, right? So v is ds dt. So in this equation, we have not written here what s is. Actually, we have not written what a is also. Anyway, we'll say s is displacement. Okay, so let me fill that up for you. So that is what s is in this particular equation. Okay, so velocity is equals to rate of change of displacement, and therefore I can write my equation on the top as ds dt equals to at. Now this kind of an equation has this derivative term, right? And this is called differential equation. So if you have in an equation a term which is like ds dt types, in that case we call that equation as a differential equation. Soon you will learn that this is ordinary first order differential equation. Now let us try to solve this equation. ds dt is equals to at. So what we can do here is, to solve this equation, to find s, we can find antiderivative and then find what s is, right? So derivative and antiderivative are just the reverse things. So derivative, antiderivative of ds dt will be s. So we get s here on the left side just by finding antiderivative. Now we have to figure out what term should be here so that its derivative becomes at. Well, that should be at square divided by 2, right? Now if I find derivative of this, it will give me 2at, and 2 and 2 cancel out, we get 80. So it works perfectly fine. As you know, for such equations, there could be any constant related with it. So we normally, when find antiderivative, we give a general solution by adding this constant c. Knowing initial conditions, we can find what c is, right? So what are the initial conditions here? Let's look at this point. So here, what do we see? At t equals to 0, velocity is 0. That means the object has not moved, right? So the object didn't move, and therefore it implies that s is also equal to 0, right? So if I substitute these values here, we get c. So we could write s is 0 equals to a, let me write half, right, 2, and t is 0 plus c. So from here we can write what c is. Clearly, c is equals to 0. Perfect. So we get the value of c, and that gives us the relation between displacement, acceleration, and time in a different form though. So we could write this equation here as s equals to half a t square, since we found that c is equals to 0. So that is a specific solution for the given situation where velocity is proportional to the time elapsed, right? So if the object didn't move, there was no displacement to start with, right? Now, s equals to half a t square is extremely important equation for us. We'll highlight this one also, right? So that is it. But what we need to get is v square equals to 2as. How do we get to that place? Okay, let's look into this equation once again. We have this equation as s equals to half a t square. We need 2 times as on one side. So let me multiply both sides by 2a, right? So if I multiply this side by 2a and also this side by 2a, what do I get? Let us simplify. So when you simplify, you get 2as equals to, and on this side, this cancels off, right? This 2 cancels with that, and you get a square t squared. Do you see that? So what you get here is 2as equals to at whole square. Now what is at? So now it's time to number these equations. First equation was this one, second was that one. So if I sub from equation 1, at is v, right? So we could write this as 2as equals to v square, or we got what we wanted, v square equals to 2as. I hope that is absolutely clear, right? So that becomes equation number 3 for us, and these 3 are very basic equations to solve most of the questions on rectilinear motion. I hope you understand and appreciate it. You can always like my videos if you like, and don't forget to share and subscribe. I'm Anil Kumar. Thanks a lot for watching.